So when we talk about the formation of the star, it depends on the amount of the matter which is available to form a star. So how a star start? The star always start with an interstellar cloud. What is the interstellar cloud? Interstellar cloud, what it consists of? It is actually a combination of the dust and the gases, usually hydrogen and helium. So in the space, we have hydrogen, helium, and the dust. So when we have lot of interstellar dust together, what will happen? It will start to form a star. How it will form a star? Formation of a star depending on the amount of interstellar cloud, the size. Sometime the interstellar cloud is very small and not very small, like same like or 4 times the mass of a sun. Sometime the interstellar cloud is so big. So the two types of a star, if an interstellar cloud is less than 4 times the mass of a sun, we call them as a low mass star. But if the interstellar cloud is more than the 4 times the mass of the sun, we call them as a high mass star. So we have two types of star, high mass and the low mass star, which start with an interstellar cloud. What is an interstellar cloud? Interstellar cloud consists of dust and gas. But what is the difference between the low mass and the high mass star? The low mass and the high mass star contain different amount of a dust and a gas. A high mass contain a greater amount where low mass contain a smaller amount. So first, how the star started? The star started with an interstellar cloud, or we also call a nebula. As you can see here, these are the images. Some nebulas are like pillars of the universe. Crab Nebula is there. Cat Eye Nebula is there. So this is how the interstellar cloud look like. Means dust is there, gases are there together. So as you can see, as a star began, how the star started? It started with the dust and the gases. What will happen as these dust particles in the space, they also have a gravity. Everything which is having a mass will have a gravity. So this dust and the gas particles, they try to attract each other, and as a force of a gravitational force, they try to pull each other towards one point because of the gravitational force. When they pull all the nearby dust and the gases towards one point, what will happen to the size of the interstellar cloud? The size of the interstellar cloud decreases. So like let's say this was original size of the interstellar cloud, but as the particles coming closer to each other, they clump together, and the gravitational force, has more mass is there. When more mass is there, as a result, what will happen? They will pull everything towards the center. When they will pull everything towards the center, so the size of the interstellar cloud decreases. Because of the gravity, the number of the particles are not changing. It's the same number of the particle, but because of the gravitational force, they pull everything towards the center, and the size of this nebula will decrease, or the size of this interstellar cloud will decrease. But what will happen to temperature? The temperature increases. Why the temperature is increasing? Because here you will have large space. So in a large space, the particles are moving, less collisions are there between them. But the same number of the particles in a small space. So as a result, what will happen? These particles will collide often. They will move faster. So as they will move faster, the temperature of the molecular cloud or interstellar cloud start to increase. As the temperature start to increase, this temperature, as the particles come closer, so this was, what is a star? Then there's a cycle of the star. So first is the nebula. What is a nebula? The birth of a star, in which The birthplace of a star, we can also say, rather than, because it's like interstellar cloud, dust, all will come closer to each other, attract each other, and pull everything towards the center. So the size of the interstellar cloud decreases. When the size of the interstellar cloud decreases, what it will form? It will form a first stage of a star, which is known as the protostar. So what happened in a protostar? So as like it started with the interstellar cloud, let's say this was an interstellar cloud, the gravity, as the particles come closer, the size of interstellar clouds start to decrease because they pull everything toward the center. So in a small space, there will be more particles, like more particles in a unit volume, and the temperature is higher. The temperature is around 10 million Kelvin. So now what will happen as the interstellar cloud come closer to each other, the size decreases, and what we call that as a protostar. Protostar is refers to the first stage of the star. And as a result, when the temperatures start to increase, it started a fusion. The fusion is started in the core. As a fusion is started in the core, what fusion it started? It started the hydrogen fusion. Like the lighter nuclei, the hydrogen atoms start to fuse together and they're forming helium and it is releasing energy. So when the lighter nuclei join and form a heavy nucleus, it releases energy. So the energy is going out in the form of heat and light. So why the temperature is increasing? Because when the size decrease, here you will have same number of the particles, but in a large space, so less collision, moving slower. But this here what happened, as the gravity is pulling everything together, so the particles come closer, they will collide more often. As a result of a often collision, the particles start to speed up. When they speed up, the temperature increase. As a result of a temperature increase, what will happen? The star will have two things. One is the radiation pressure. One is the pressure of the radiation which is going outward. Another one is the gravity which is pulling everything towards the center. So gravity try to pull the things towards the center and the radiation try to push everything out. So in a protostar, like how a nebula convert into a protostar, a nebula, everything coming closer, as it come closer, the temperature start to increase. As the temperatures start to increase, it start a fusion and which start to release energy. So when the fusion started in a star, what we call this star, we call that as a protostar. So when everything was coming closer, it was nebula or molecular cloud, you can say. But when in a molecular cloud, it comes so close that it start to fuse, what we call that as a proto star. Then after a protostar, we call a main sequence star. What is the main sequence star? The main sequence star is the star which is having the same radiation pressure and the gravitational force. So it does not change its size. Because for a star, every star, the gravity is there, which is pulling everything towards the center. So there's a gravitational force which is pulling everything towards the center. And the star, the core of the star is undergoing a fusion reaction. Which fusion? It's a hydrogen fusion. So because of the fusion reaction, it is releasing energy to the surrounding. So the radiation pressure is outward. What we call a main sequence star, a star is known as a main sequence star when its radiation pressure is equal to the gravitational force. The pressure due to radiation is balanced with the gravity. And what is the best example of a main sequence star? The best example of a main sequence star is our sun. Our sun is actually a main sequence star. You don't find the size of the sun is changing. So why the size of a sun is not changing? Because what happened on the sun is producing energy. the pressure which is like, because of a radiation, the particles are pushed out, and because of the gravity, the particles are pulled. So if I say there's one particle, if I push with a force of 20 Newton or 2 Newton and I pull with a force of 2 Newton, where this particle will go? It will remain at its place. So same thing happen for a star. Yes, you can also say a thermal pressure or a radiation pressure. Radiation pressure I use because it's more, it's a scientific term normally used, but it's fine if you use a thermal pressure. So actually what happened, the pressure of the radiation balances with the force of a gravity. So the star does not change the size. And what we call that as a main sequence star. So our sun is actually a main sequence star. Why our sun is a main sequence star? Because the radiation pressure, the sun is emitting out radiation. How it is emitting out radiation? By undergoing a nuclear fusion. So the nuclear fusion releases energy outward. And the gravity is pulling towards the center. But because these two forces are same, so as a result, two are same, what will happen? We'll have the same size of a sun. The sun size does not increase or decrease. If the radiation pressure is higher, then what should happen to the size of the star? Should it increase or decrease? If the radiation pressure is higher?
Increase.
Increase. So that is what is predicted to happen to our sun. When the sun will start a helium fusion, the size of the sun will increase, and even it will take the orbit of the Mercury and Venus. If the sun, this is a predicted, what will happen when the sun will turn into another type of a star? We call that as a red giant. Yes, I will come to a red giant term. But when the sun size will increase, it will take the orbit of the Mercury and Venus. Right now, our sun is a main sequence star. When we say that the sun temperature, when we say that the sun is a main sequence star, what is the meaning of the term main sequence star? The term main sequence means that the size of the star does not change, and the star remain in a main sequence for a very long duration. So sun is expected to remain in this main sequence for a very long duration. Is it clear till this point, the main sequence concept?
Yes, sir.
Okay. Then what will be the next stage of a star? The next stage of a star is called a red giant or a supergiant. The star might turn into a red giant or a supergiant. It depends on the size of the star. What will happen to the star once the star finishes hydrogen fusion? Like on our sun, we have plenty of hydrogen and it undergo a hydrogen fusion. But eventually what will happen? The sun will run out of the hydrogen. So sun will run out of a hydrogen. When it run out of a hydrogen, it will start helium fusion. When it start a helium fusion, when it start the helium fusion, as a result of the helium fusion, it will start to release energy and the radiation pressure will increase. The radiation pressure will be higher. As the radiation pressure is higher than the gravitational force, so what will happen? The size of the star will increase, and what we call that as a red giant or supergiant. Giant or supergiant depends on the mass of the star. Like if it is like 4 times the mass of a sun or less than 4 times the mass of a sun, it will likely to be a red giant. But if it is more than the 4 times the mass of the sun, then it will called as a supergiant. So our sun expected to turn into a red giant, and when it turned into a red giant, you can clearly see, like here we have Mercury, Venus and Earth. So it will take the orbit of the Mercury and Venus. So we will be very close, and it is impossible for that temperature for a human life or a life to survive. Well, because that will be very high temperature on the Earth. So even you will not get